Hey everyone, I'm Priyanka from Computer Science and Engineering Department. Today we are going to discuss a topic on study of TCP flow and congestion control mechanism impact on internet environment. Let's get into the topic. First of all, let us see what does mean by transition control protocol TCP. The transition control protocol TCP is connection oriented, reliable and end-to-end protocol that support flow and congestion control. With the evolution and rapid growth of the internet and emergence of internet of things, IoT, flow and congestion have clear impact in the network performance. TCP is intended to provide a reliable process to continuous stream of objects in a multi-network environment. The TCP is intended to a host-to-host protocol in common use in multiple networks. Overview of TCP congestion control mechanism. Congestion control algorithm. TCP Tahoe. TCP Tahoe based on TCP congestion control algorithm, which was connection obey conservation of packets principle. The protocol is self-clocking. New packet isn't put into the network until an old packet leaves. TCP Reno. TCP Reno retains implementation of the basic principle of Tahoe such as slow starts but add modification to the congestion avoidance algorithm. TCP New Reno modified fast recovery algorithm in RFC 2581. The TCP data sender responds to a partial acknowledgement by inferring that the next in sequence packet has been lost and retransmitting that packet. New Reno includes a small change to a Reno algorithm at the sender that eliminates Reno's wait for a retransmit timer when multiple packets are lost from a window. TCP SAC. With selective acknowledgement, the data receiver can inform the sender about all the segments that have arrived successfully, so the sender need retransmit only the segments that have actually been lost. TCP Vegas. TCP Vegas is a modification of Reno implementation which introduced to provide some new insights into congestion control and to propose modification to the implementation of TCP that exploit these insights. It employs three techniques to increase throughput and decrease losses. TCP congestion control procedure. Here are the diagram for the TCP congestion control procedures. TCP congestion control procedure follows when congestion occurs. The retransmission is needed to recover a missing packet in slow start phase. The end growing potentially until it reaches the threshold. After that, the congestion avoidance phase start and the value of a threshold is set to half of the current window size and EWND is set to the value of threshold. Then the EWND size increase linearly until 3 ACKs arrive to the sender or timeout event occur. When their ACKs happens, TCP start fast transmission and fast recovery phase and multiplicative decrease procedure take over, and the over value of threshold is set to the half of current window size and the value of CWND is set to the threshold value and congestion avoidance phase start. In the second case, if timeout occur at this moment, the multiplicative decrease starts and reduce the threshold value to half of the current window size and EWND is set to one segment. TCP enter slow start phase again. Timeout and retransmission. TCP provides reliability when data segments and acknowledgement can get lost. It handles this by setting a timeout when it sends data, and if the data isn't acknowledged when the timeout expires, it retransmits the data. Round trip time measurements. TCP must measure the RTT between sending a byte and receiving an acknowledgement. When we use the following equations that are applied to each RTT measurement M. Thank you.